All right, welcome TOK students. We are here for the third installment of Ask a Diploma Program Teacher. Here we're talking about the natural sciences, and we are here with the natural sciences head of department, Miss Borrowman, who has multiple years of experience in the diploma program. She's taught a number of different courses in the sciences. We're in good hands here to think about what is the connection between the sciences and TOK. So Ms. Borrowman, I'll start you off with an easy one, okay? A fastball down the middle.
All right.
Yeah? What makes knowledge scientific?
All right. So when we use the term scientific, we are referring to a very methodical way in which we obtain knowledge. That's the biggest thing when we think about that term scientific. We just don't gather information without a plan, without certain steps being taken. There's a certain way to gather that information. And the reason for that is to eliminate any belief or opinions that go into that knowledge. So when we talk about scientific, we're talking about a very methodical way to gain that knowledge.
Yeah, so that's kind of what separates the natural sciences from a lot of other areas of knowledge in TOK, and that the sciences are very methodical, probably the most methodical of the 5 areas of knowledge where something like the arts probably has some conventions about things that artists should be doing, but there's no artistic method, as it were.
Mm-hmm.
Yeah, cool. Okay, second question. You're doing great. Is prediction the primary purpose of scientific knowledge?
So prediction. So prediction is a part of that scientific method. And in order to be able to go about collecting information, data, knowledge, we start with a prediction. We always want to have that idea of what should come about with an experiment or collecting data and whatever it is. But I would probably argue that it's not necessarily the primary purpose. I would say the primary purpose, why do we go through this scientific method to collect scientific knowledge, is because of curiosity, as well as to obtain that knowledge that is driven through truth and facts. When scientists go through a type of, say, experiment, that they are gathering this data to be analyzed and come to some type of conclusion that honestly may go against a prediction. And that's sort of the purpose of scientific knowledge, because it's not supposed to be about somebody's agenda or wants or beliefs. And so prediction, yeah, we may make a prediction of what we want to have happen or should happen, but that doesn't necessarily mean it is going to. So I would definitely argue primary purpose. I wouldn't say primary purpose, but I would say there is a purpose to prediction within obtaining scientific knowledge.
Okay. What if we changed the question slightly?
Okay.
And we said, is explanation the primary purpose of scientific knowledge?
And I probably would agree on that, because yeah, that is the purpose. We're always curious to understand more things about the world, or curious as to how certain things are happening or going on. And then we go through an experiment and we have these results. The biggest thing about the results is to then explain those results. That is extremely important. So I would say, yeah, explanation is probably a big primary purpose for scientific knowledge. Yes.
Cool. Okay, question number 3. Um, the realm of the natural sciences has been subject to a lot of different changes. And this is a bit of an Easter egg for my last question for you. So,
Okay.
how can it be that scientific knowledge changes over time?
Yeah, this is a big question, a really great question. And I think in the simplest terms that over time we have made new discoveries. We have more technologies. We've been able to utilize technologies in a different way. And what happens is that we have been able to obtain more knowledge. We've been able to obtain, say, better results, or even maybe different results, because of new technologies, new discoveries. And therefore, that leads to changing that scientific knowledge. Um, if we think about just history, 100 years ago or so, we knew that there was some genetic material that made us who we are, but that's about it. And it took discoveries and technologies to be able to, say, sequence the human genome so we can see the details of that DNA. Our idea of genetic material changed with that new discovery, with that new technology. And so with our, discovering and new processes, new things that come up, it's always going to change. Ideally, we would like to say it's changing for the better, but it is always going to change. I think another big, huge example that I can give off the top of my head that's relevant currently right now is about the COVID virus. In the very beginning, if you remember back to, say, March, April of 2020, here in the United States, we didn't know too much about the virus. And so the CDC came out with a recommendation that, like, if you were ill or not feeling well, had to be in public, you wore a mask. But if you didn't, if you felt fine, you didn't have to wear a mask. Well, then we started researching the virus and getting more information, and all of a sudden then that changed to, yeah, it's more transmittable than we thought. It is extremely important now that everyone wears a mask. So it was new knowledge that we gained through just, discovering what was going on with the virus, that those CDC recommendations change. So to me, science is always changing, and it's a good thing because we're keeping up with the world around us.
Yeah. It sounds like what you're saying there is that more time equals more opportunity for experiments, and that's really the heart of producing knowledge in the sciences.
Yes,
Yeah,
definitely.
cool. So as head of department, you sort of oversee what's going on in the 3 sort of diploma program subjects that we offer in group 4 here, with chemistry, biology, and physics. And each of those
Mhm,
are natural sciences, but they're
mhm.
fundamentally different in what they're trying to investigate. So,
Yep.
question to that is there a single scientific method?
Oof. Um, so that definitely is a question that a lot of scientists ask. And I would say the best answer is yes and no. I would say in general, there is a very overall uniform way that scientists approach an experiment. They want to be able to collect data in a certain way, analyze it to be able to form conclusions. Those specific steps, if you would want to say, step 1, step 2, step 3 of the scientific method, I believe that's where in those details it can change. Ideally, you want to have a hypothesis and a prediction prior to you setting up an experiment. But sometimes you need to run an experiment prior to creating a formalized hypothesis and prediction. So sometimes you do a preliminary experiment to see what happens in order to move forward. So I would say definitely there's a methodical way to do it that scientists call that the scientific method, but the actual steps of the scientific method can change depending on what you're trying to look at.
Okay, you smashed that one. Good job.
Thank you.
So the last one deals with ethics in the natural sciences, and I kind of call this the TOK ethics trap. So what we got to be careful to not do in TOK is try to decide is a particular action ethical or not ethical, because that would be something more along the lines of an ethics class, right? But what we are interested in thinking about with TOK is how do our sort of ethical frameworks that we use, how does that determine sort of what we look into, right? So we've talked about this in TOK even as recently as today. How do the values scientists possess determine how they practice science?
All right, so values are extremely important, especially in the sciences, because as a scientist, you are going through an experiment. You have collected data, you analyze it, and you come up with results or a conclusion. And there are times where scientists go through this process and they're thinking that they are going to have these certain results. And at the end, they don't. And that's, where sort of the values come in, as the results are what they are. And as a scientist, you have to value the process, and you have to value that scientific method, and you have to value the experimental process and the data that you have collected. Otherwise, it's not scientific. And so values that scientists possess are going to be extremely important in keeping science and scientific knowledge what it's supposed to be. Otherwise, we do start getting into the more I believe statements or in my opinion statements, which is not what scientific knowledge is supposed to be. And this can come into like many forms, just depending on what the scientists are doing. Unfortunately, science does cost money. And so sometimes you have companies that are wanting scientific studies done. And of course, those companies would really like certain results to happen. It's just very important that the values of a scientist be for obtaining scientific knowledge, no matter what the results are. So
it seems like people that that I know that are in the sciences or that are science teachers, one value that they have is sort of like openness. they're very open to the idea of being wrong.
Mhm.
And sometimes they even welcome.
Yes. Yes, I would totally agree with that. I think that's one thing that I also have observed with scientists that I know, who I've worked with in other fields, science teachers, because we also have read through a lot of the, historical science experiments and data. And I always tell my students, science really is 95% wrong, right? When you do an experiment, it's rarely comes out right the first time. So being wrong, even saying that is almost inappropriate. Not that the results were wrong, it was just the results you got. And then you need to work with those. So I agree that, scientists go through an experiment, they get what they get. And if it isn't what they were supposed to get, that it's good. You still got results, and results you can work with.
Right. So the idea that errors are valuable.
Yes, definitely.
Okay. So my last question for you, we've talked about this topic recently in TOK, and that is the idea of a paradigm shift.
Okay.
And that we have certain worldviews and certain assumptions that we have about the world and how it works. And then an event comes along, or a series of events come along and really shatter those worldviews, right? And I think this is
Yep.
probably, you've mentioned this a little bit about with the COVID-19 pandemic. So my last question for you is, how do you think that the COVID-19 pandemic might lead to a paradigm shift in the realm of the natural sciences?
Oof. This could be a very long answer, but I guess I would say I am hopeful that with what has been happening in the world and the scientific knowledge that we have gained from this pandemic, anywhere from how did the virus become this spreadable virus throughout the whole entire world, to what the virus genetic material is made out of, and then also the vaccines. And as I'm sure many people are aware, the vaccines that are out currently are a brand new type of vaccine with the mRNA. All of these things are new, and hopefully this then also gives people an idea that, going back to what we said before, that science is constantly changing, and ideally for the better. In addition to that, I think this pandemic has also highlighted that, scientific evidence, while it is always changing, is always valuable and needs to be considered when we're looking at, the world view of things. So I guess I would say I am hopeful that with this pandemic, we see a shift towards looking at scientists, looking at what they have been doing, what they will be doing in the future, the results of different studies, maybe doing even more studies that are going to allow us to get more of that scientific knowledge to hopefully help better, our planet, and to sort of bring about that awareness that we need right now.
Yeah, it seems like scientific knowledge has become more important in our daily lives, maybe before than what the pandemic was, right? And I think we're even sort of seeing that out
Yes.
in like the role of authorities, right?
Yes.
The
Yes.
CDC, the WHO, these people are obviously very reliant on scientific knowledge, but these authorities have become more important in our lives, but I think also increasingly sort of more questioned in their authority, because
Yes.
people are looking back and say, well, you were wrong so much, and then and that's has led to people to question, how much authority they actually have. even though they're part of the government or an international organization like the WHO. So, all right, thank you, Ms. Borrowman.
Yes.
You have provided some compelling answers to some previously unanswerable questions in the natural sciences. So, thank you for taking the time to talk to us today.
Well, thank you for asking me. I very much enjoyed talking to you.
Thanks.